Not Persian, I can't
Who
stand.
says he's not Persian?
What? Okay, that's just straight up witchcraft.
Then there's this one. Like,
There's this one, but I can't do it.
Native American.
You gotta step back.
So on your UCF, put Native American. So, what do you consider yourself?
I consider myself with scholarship and just.
Sometimes when it asks you where you're from, there's like this Native Alaskan thing, and in parentheses it says Central American. Like, I'm Central American. Does that make me Native Alaskan?
There's also, that says like for
We just love to
Alaska here, it's Central American like here.
I know, but it's
So why? There's also another one that says
Consider
parentheses American Indian. I'm like, I'm Indian.
Same.
I live in America. American Indian.
That's where the friendly goes.
Well, technically,
what if you're ethnically German, but you grew up in like Ethiopia, and your parent and you're here?
Mr. Ferreira, is it true Valerio lived in South Africa or no?
I don't know.
He always tells me that.
Mr. Ferreira knows Mr. Valera's life.
Wait, Valerius?
I've heard that before, but I don't know.
I know he went to Granada Hills.
Oh, yeah.
Wait, LeVar Ball went to Canoga. Yeah, LeVar Ball did go to Canoga.
Do you even talk to him much?
Not a whole lot outside of class. If we're at conferences and stuff,
Do you
yeah.
not remember?
FFX?
I always say, okay, that's when I see
Oh, FFX?
Oh, I get bad memories.
FFX.
She's the one who
F Prime X? Double Prime? I forget that.
You used to call it prime, and I hate it.
and it's found out today.
Double prime.
I don't miss milk at all.
Oh,
Okay, let's go ahead and get started here.
can you explain to me one of the multiple choice?
I can absolutely. Which one?
Can you explain to me number 7?
Yeah, absolutely. Number 7.
Yeah.
First of all, we need to talk about what resistant means.
Yeah, I didn't
Okay.
know that.
So, in the scope of LSRL, actually in the scope of everything, resistant means that if there's an outlier, it's not going to change the value of the statistic drastically. The thing to know is that the only statistical measurements that we've met that are resistant are the IQR, the median, and yeah, that's about it. Yeah, the 5-number summary and the IQR are the only ones. No, not even the 5-number summary. Just IQR, Q1 and Q3, and median. Those are the only ones that we've met that are resistant. Everything else is not resistant. Okay? Especially if it's a mean or a standard deviation, those are not resistant to outliers. Okay? So, when you look at number 7, which of the following are resistant? None of them say median, none of them say IQR. Nothing about the least square regression line is resistant. Okay?
Can you also go over number 10?
Of course. Let's do that now. Wait, did I? No, I didn't. Okay. 10, we have the study of fuel economy for various automobiles plotted fuel consumption versus speed. Okay. The least squares regression line was fit to the data. And this is a residual plot. So I think it's really important to know that you're not looking at a plot of fuel consumption versus speed. You're looking at a residual plot. So the y-coordinates are the values of the residuals. So if we take a look at the residual plot, there's a clear pattern. Anytime there's a clear pattern in the residual plot, that means that the linearity or using a linear model is wrong. Linearity is the wrong model to choose. So the residual plot shows a clear pattern. The linear model is not the correct model. Okay, so that being said, looking at the answer choices, the one that fits the best is D. The residual plot clearly contradicts linearity of data. Okay? C and D are kind of similar. But I think the more I think about this, it's like nothing is really going to confirm linearity. You know, it's there's no way of actually knowing the equation that fits dependent variable with independent variable. So nothing's going to confirm that linearity, really. Okay. This was 11 down here, right? Okay. Any other ones you want to hit before we just go down the line? Okay. Well, we'll just go down the line here. Number one is, well, we have the data clearly. Okay, maybe I shouldn't say things like clearly, but the data looks, first of all, like it has a negative slope. Negative slope or negative what's the word? Correlation? Negative association. Negative association. Yeah. Negative association for sure. Does it look linear?
Yeah.
Yeah, it looks pretty linear. It looks like it could be aligned. If you were going to draw some kind of a relationship on that chart, you would probably draw a straight line. Okay, negative association, data looks linear. Maybe we should say it doesn't look curved. So yeah, is a scatter plot tightly clustered around a line? Based on the scale, it looks like they're all pretty close to where that line would be. In other words, you can almost see where the line is. So, hey,
I forgot.
okay. The data is closely clustered into a line. So, all that put together says that the, what is that? The correlation coefficient. Ooh, what happened? R should be close to -1. Values of correlation that are close to 1 are almost linear or strongly linear with a positive slope. Values that are close to -1 are strongly linear with a negative slope. Close to 0 means that a weak correlation. Okay. 2. Scatter plot in the previous question, if each x value was decreased by 1 unit and the y values would remain the same, correlation would, well, that's not going to change the relationship of the points to each other, right? You're basically going to take that entire scatter plot and you would just shift it down 1 unit, right? Is that right? The y coordinates are, oh, I'm sorry, the x coordinates are decreased by 1. So the entire scatter plot would shift to the left. The scatter plot would shift to the left, but the shape slash relationship would remain the same. So if you're not changing where the points are in relation to each other, you're not changing correlation. Since this is a rigid transformation, the correlation would stay the same. Remember, rigid transformation means translations left and right, up and down. It also means a reflection, but I don't think we want to deal with reflections here. For us, it's just say this: translations up and down are not going to change. Okay. 3. In regression, residuals are, we have that handy definition of residual, right? The residual is equal to the actual minus predicted. So anything that's close to actual minus predicted is going to be our choice here. Residuals are factors that are unexplained by data. Okay, no. That's something that we said earlier in the textbook, so it sounds plausible, or it sounds like a legit statistical thing. That's not what residuals are. The difference between the observed responses and the predicted responses. Difference means subtraction. Is observed the same thing as actual? Yes, it is. And predicted values of the regression line, yeah, actual minus predicted, observed minus predicted. B sounds like a winner. C, data points which were recorded after a formal investigation was completed. I don't even know what they're trying to say there. D, possible models unexplored by the investigator. Again, that sounds pretty good, but it doesn't have anything to do with residuals. So B is our correct answer. B, right? Yeah, B. Good. 4. A local community college announces a correlation between college entrance exam and scholastic achievements was found to be negative 1.08. Yeah, that's correlation coefficient R. The absolute value of R needs to be less than or equal to 1. Clearly, this is gibberish. So D, the college should hire a new statistician. That's the book trying to be a little bit cheeky, okay?
You should put that one on there.
Should put that one on the test. Okay, I'll see what I can do. Not that I didn't photocopy the test like a month ago or anything. It's still summer. 5, a researcher finds that correlation between greed and superciliousness is negative 0.4. What percent of the variation of greed can be explained by a relationship with superciliousness? That sounds like a really good question. It sounds like something you could actually compute. And with any other variables, you would be able to compute that. But these aren't numerical values.
With numerical values, would you just square it?
Yeah, if the variables were numeric, you would just square it. Yeah. So the data isn't numerical. Correlation does not make sense in this context. And then what do we say if the data was numerical? If the data was numerical. Sounds like we're talking about OJ's book. If I did do it, this is what I would have done. If the data was numerical, then percent variation explained by a linear relationship, that's equal to R squared.
Wait, so R squared is like the percent error or something like that?
It's actually a percent decrease of the error.
Okay.
I like to think that it's like what percentage or how much better is using a linear relationship than not using a linear relationship. 72% better. R squared better. Let's also note that you're never going to have to actually compute r squared with the crazy formula. You just have to either grab it from your calculator or from whatever statistical things are given to you. 6. Suppose you have the following data. X is the diameter of tree trunk. Y is the tree height. We have an LSRL. Y hat is equal to, I don't know why we forgot the hat here. Y hat equals negative 3.6 plus 3.1x. What is your estimate of the average height of all the trees having a trunk diameter of 7? Okay, well that just sounds like you're supposed to plug 7 into the equation, right? So y hat is going to be equal to, what is that, negative 3.6? Yeah, have a nice day. 3.1 times 7, yeah? 18.1. What's our units? Inches.
Is it feet, I think.
Is it feet?
I think so.
I was going to say an 18-inch tree with a 7-foot diameter trunk. It's a very short and squat tree. Oh, that's funny. We talked about 7, right? Let's look at 8. A data set A of XY data has a correlation of 0.65. Wait. Does that make sense, 0.65? Yes, it does. Second data set has a correlation of negative 0.65. Ooh, that's weird. They're like the same correlation, but one's positive, one's negative. Okay, if that's true, then, I got to go through all of these and figure out which one is good and which one is bad. So basically they're asking which is true, right? A. Is A true? Eric, what did your shirt say? Keep calm, the Russian is here. Okay. Did you wear that to the elections?
No, I wore this today.
Yo, what are you wearing tomorrow?
I messaged you to open this door.
Oh.
You open it.
Wait.
What a jerk.
I didn't know you were here.
Can you open the door to C building, please? Well,
Wait, is please the second message?
Yeah.
I saw the B building was open. So I walked
You
around.
walked all the way around?
But I'm here now.
Well,
Okay. We won't worry about it anymore then. Okay,
You picked up.
the points in A exhibit a stronger linear relationship than B. The points in B exhibit a stronger linear relationship than A. So with A and B, since both values of R since both values of the absolute value of R are 6.5, they would seem to have the same strength.
So it doesn't matter if it's negative or positive.
Yeah.
Okay.
Now, all that negative or positive does is tell you if the slope is positive or negative. But there's actually more to this question, because we don't actually know if the scatter plot is linear. Okay, just because we can compute an R doesn't make the data any more or less linear. So we actually don't know if there is a linear association. C is a confirmation of above. But what are you saying? We can't tell if the data is actually linear without visually inspecting the scatter plot.
For a plot to be, or a
0.75 and up.
So 3/4 and higher.
3/4 and higher, yeah. But you have to, basically the story with this one is, you have to look at the scatter plot to confirm linearity. There is no statistic. There is no statistic that will confirm linearity. Okay. You have to look at it. Even if the correlation is 1, you have to look at it. Yeah. Although I think it would be pretty amazing to see a correlation of 1. Okay, does 8 make sense? Got to look at the data. You can't say anything is linear, regardless of what numbers they throw at you. You can't confirm something as being linear until you look at the scatter plots. Okay? Alright, number 9 we did in both classes, right? Number 10 we just did. It's kind of the same thing. You've got to look at the, well, no, if the residual plot shows that clear pattern, that means that your linear model is the wrong model.
So what would be an example of a pattern as a parabola?
Yeah.
I mean, is there really anything else that
It could look like an S curve,
Oh, okay.
you know?
If it doesn't look right, it's
Yeah.
Okay.
If it doesn't look like a randomized cluster around, then it's bad news. Okay. Okay, where are we at now? 11 we all talked about in class. We're on 12 then, right?
Yes.
Yeah. LSRL. And I think I made a pretty good talk about LSRL in period 3. But the LSRL is just anything, anytime we compute a least squares regression line and we use this equation for B and we use this equation for A, we're making an LSRL. If you're using your calculator to make a regression line, it is making an LSRL. Or maybe to put it another way, we don't know how to do a regression line other than an LSRL. That's the only regression line we know how to make.
So when it's just saying LSRL, it just means make a regression line?
Yep. LSRL means make a regression line like we always do in class. Okay, so an LSRL predicts the height of a tree in the first 10 weeks outside nursery to be y hat equals 3.2 plus 1.8x, where y hat is predicted height in inches and x is the number of weeks outside the nursery. Interpret the meanings of the y-intercept A and the slope B in terms of the data provided. Okay, so for letter a tree that spends, what is x? Number of weeks, right? 0 weeks outside the nursery is predicted to have a height of, what's A? 3.2
Yeah.
units, inches. Why does that say B? That should say A, right? Okay, what else? For every increase of 1 week outside the nursery, a tree is expected to grow. And this is where that part, you have to interpret it a little bit. We're talking about trees growing taller. So we're expecting it to grow 1.8 inches.
say the word expected, or can you use predicted also?
Predicted or expected would work. Predicted / expected. B. Estimate the height of a tree that's been out of the nursery for 6 weeks. No problem. We just chuck that into the equation. 3.2 plus 1.8 multiplied by 6 weeks. That's equal to, oh, why didn't you work? 14 inches. Also notice that since y hat was defined for me in the problem, I don't have to actually say what y hat is. If I didn't have y hat, or if I didn't have y, what am I trying to say, defined, then it would be up to me to say what y is equal to.
Would you ever have to define A and B?
No. Those parameter values like a and b are always the same. It's always slope and y-intercept. Okay. Context you'd have to provide, like we did in part A. But what they actually are, you don't have to do. It's assumed to be slope and y-intercept. C. Explain no, wrong one. The actual height of a tree found to be 6 weeks out of the nursery is equal to 12.5 inches. Calculate the residual. Awesome, I hope I get that question. Residual is equal to actual minus predicted. I know I misspelled that. I know I misspelled that one too. Actual is 12.5 inches. Predicted was 14 inches. We over predicted, so we have a negative residual of 1.5. Oh, I botched that up too, huh?
Imagine writing a stats book in this way.
I learned a while ago that it's way easier to spell check at the end. Just type all the wrong words, spell check at the very end. You end up saving a lot of time.
Is that good advice for the lecture class?
Huh?
Like in college, in a lecture, if the teacher talks fast, just like...
Yeah, just write it.
But then when you read it, you wouldn't understand what you wrote.
You'll understand it. I hope you'll understand it. 12 and 13. Okay, so that's it for the free response questions. Since we've gone over them, is there anything from those that you want to review? Yeah, Bibi. Bibi, did you leave your spiral bound here? Did you leave a spiral bound here? A spiral bound notebook? Did you lose one? Because one of them appeared here. I don't know who it belongs to. So I feel like it's either you, or it's Carly's, or it's Brendan. Yeah.
It's probably Carly.
Ah.
No, serious.
She's being real here, yeah?
She was
Might be Carly's. Okay.
She's my best friend. I can do whatever. She's my best friend. I can talk whatever I want. Anytime you choose.
That's not what she says. That's not what she told me.
That's what she told you?
That's not what she told me. I'm kidding.
I don't like this conversation anymore.
I'm kidding.
She goes like every week. They're so jealous.
Okay, last one I want to look at is FRQ4.
This is amazing. It's the best channel ever.
Okay. So,
You can't say fuck you.
Joey appears to be growing slowly as a toddler. His height between 18 and 30 months of age increases with as follows. Notice we have a busted chart. We've got a lot of numbers that are not in there. We fit a least squares regression line. So, well, first of all, we have to fill in this chart. So what do we have? We have age.
Keep it real.
Keep it real. We have observed. We've got predicted. We've got residual. All right, so the first one is 18. Observed here is 76.5. Predicted, we don't know, so let's call that A. Residual is negative 0.08. Next line at 21, we have 78.7. We have 7909. And we have an unknown here, we'll call that B. Next one is at 24. We have an unknown here, let's call that C. 81.6 and 0.4 for the residual. What did I just do?
So this was like fill in the blank.
This is fill in the blank, yeah.
Oh, really?
27, we have 84.8. D. 0.69. Next one we have a blank, 86. 8662.
Oh,
And
are these totals?
negative 0.62. Yeah, you're right, that's E.
Wrong. You're wrong. So I'm not totals. Just mess with the exam time. Well, I answered Grady's question. Oh.
Okay, we can get all of these just using basic algebra. So to get A, we have observed minus predicted, 76.5 minus A is equal to negative 0.08. And then you solve for that. What is that? 77.3. Algebra. A equals 77.3, I think. 76.58.
So they hear like all of our dumb comments.
They do, but they're intelligent comments. 78.7 minus 79.09. That's equal to that, which should be equal to B. No. Should be equal to B. No algebra to do on that one. It's just straight up subtraction. To get C, we have C minus 81.6 equals 0.4. We use algebra. And that gives me C equals,
You goofed up a little bit.
I did?
Yeah, you did it equals a negative 81.6.
Oh, I see what happened here. Like that?
Yeah.
Okay, so that's what, 82?
Yes, sir.
C equals 82.
Fixed it.
Line D, we have 84.8 minus D equals 0.69. Again, we use algebra. We get D is equal to, oh boy, what is this? 84.11, 84.11?
I think so.
For E, we'll have to use the LSRL. Okay. So we have 61.5.
Well, I would assume
Plus,
that is 30,
yeah, it's a good guess. It probably is 30.
because in the later question it says 18 to 30 months. And why would they
Zero
put 30
eight
months?
three seven times E. That should be equal to 86.62. Do some algebra. And yeah, E equals 30. Okay, so that's finishing that. Residual plot for part B is a plot of residuals versus age in this case, since age is the independent variable. Okay. This is in the answer key, right? Yeah, it's in the answer key. See answer key. See?
So is the residual always going to be the x-axis?
Residual is y-axis.
Oh, okay. I mixed it up. Yeah.
Did I have this backwards? Yeah, I do have this
Yeah, it's
backwards. Yeah.
residual.
My bad. C. Based on your residual plot, would you describe as being linear? And that's a trick question again, right? You can't tell if something is actually linear until you look at the scatter plot. So, bit of a trick question.
According to the law I'm looking at it, yeah, it doesn't look yeah,
Well, I mean, it doesn't look like there's a pattern, so
yeah. All I see is a pattern in these 3 points. Other than that, it's just like,
no, but since there isn't a pattern, it wouldn't be linear.
You can't really tell.
no, bro, it looks like an upside down parabola. That's not
That's the residual plot will be linear, since it does not show a pattern. Oh, wait, since it does show an unstructured scatter of points. So it would be considered linear.
You can't really tell by the residual plot alone. If the residual plot shows no pattern, and the age versus height, then we would describe linear. So yeah, I'd want to plot age versus observed as well. Predict Joy's height as at 20 months. So at 20 months,
Wait, Mr. Fleury?
yeah,
If on the test, if you put the answer like on the answer key, that it would seem plausible that it's linear since it doesn't show a pattern, would that be fine, or should we put that?
I don't like the way the question was handled.
Okay.
Yeah.
So on the test, it would be more like.
Yeah, I would want you to make mention of the scatter plot of the data needs to look linear as well.
Okay.
But like, so in this case, like if you look at the scatter plot, it doesn't look linear. It just looks all over the place. Would we still consider that as linear, or would we just say it's hard to assume that it's linear? More information is needed.
So you're saying the scatter plot doesn't look linear
It doesn't look linear to me.
Do you want to see it?
It looks sort of.
over here?
Okay. Yeah.
Well, no. That plot that is the residual plot.
Right.
The residual plot needs to be unstructured.
Okay.
Okay, but the scatter plot of the data has to look linear.
Oh, okay.
Okay, so it's kind of like, what plot am I looking at?
Okay.
One of the
So
plots.
the residual plot is meant to be all over the place.
Yes.
Okay.
Residual plot's meant to be all over the place. Scatter plot of the data is supposed to look linear.
All right.
Predict Joy's height at 20 months, you're going to use the LSRL. So at 20 months, y hat,
It's supposed to be letter D.
I don't know how to count. Y hat equals times 20. So that's 78.24, what is that, inches?
No.
Centimeters?
Oh, maybe.
Centimeters? Oh yeah, that's like a 7-foot baby, right? 6 foot baby, 6 foot tall baby.
Yeah, makes sense.
That's a big baby.
Yes, it does.
I was born 10 pounds.
Is that heavy?
I mean, the average like 6.5. So.
I don't.
So
That's
you
heavy.
came out ready to go to college.
Of course. I came out taking AP classes.
He came out this
She was
fall.
the outlier.
He came out.
It was the outlier, but it wasn't resistant. So.
The average was 6 feet in the outlier.
Okay, I'm gonna shut this off. If there's any questions.
Whoa.